everyone, this is Benjamin Malunda. Welcome to my channel Learn a Lot. And today I will interest you on a tutorial that will focus on extracting water features using object-based classification. We are continuing with our series. If you did not watch the first tutorial where I introduced eCognition, you can check the section below in the comment section, in the description section, where I actually put the link to the previous video so you can watch and see what we discussed in the previous video. But on this one, we are mainly going to focus on how we can extract water features using eCognition. So we are going to start by creating a new rule set. We're going to call it classification. We're gonna call it, no, sorry, why am I saying classification? This is where I meant to type it. Classification. We're gonna say classification, and then on the execute child process, we're gonna leave it as execute child process, and then say okay. Then we're gonna append the child, and then in the child process, we're gonna call the multi-resolution segmentation process. And then we're going to keep it at pixel level, and then we're going to name it to level 1. And so we're going to assign a weight of 2 to near infrared. We're going to give that 50 scale parameter, and then we're going to say 0.2 and then 0.8 there. You can check the previous video as to why I'm setting up all these parameters. But just a quick recap, we're giving a weight of 2 to near infrared because the near infrared highlights water features and vegetation better than any other layer. And then the scale parameter, we want when we're creating our object layer, we want bigger object layers instead of smaller object, which might take longer. And then we take compactness to be much more because water features are expected to be compacted rather than scattered around. We're going to say okay, or you can click execute if you wish to. The process might take a while, so just be patient. Okay, so our process has ended. It took about 2 minutes and 3 seconds to run our image segmentation. So this is how our image segmentation looks like. Wow, it's quite messy, I know. But the advantage here is now, if you click on any segmentation, you get your near infrared and brightness values. You can actually see what they represent. So if we we open, for example, the near infrared, the mean near infrared layer, if we display it there, we can actually set a threshold, let's say from 0 to 400. As you can see, features are being highlighted. The other water body has lower near infrared, so you see them appearing darker than every other features, but you can see that at 400 already we've got a good representation of what our water features are. If we put it to 450, you can see that the water body is already well classified there. I am just gonna zoom in quickly to see if we've got any discrepancies anyway. No, it appears to be very well classified if we stretch it to 450. So let's see if we put to 500. It is well identified. Sorry, I have gone out of the infrared image. That's so. Yeah, okay, no, we're fine. But you see that there are other classes that have been misclassified. The only way we can do this is if we add an additional layer to these ones. So we're gonna say select features to display. I'm gonna create a customized one, a customized algorithm, which I'm gonna call NDVI, because NDVI separates our water features better So we're gonna select the near infrared layer. We're gonna extract the red infrared layer. I hope you know the formulas for these ones. You can always Google them to see what's the formula for NDVI. Then it's gonna be that plus the red. Then we close. We shall apply that. Then we shall say OK. And then we want it to be amongst the features that was displayed, right? So you got an NDVI value there. So for example, these other features that have been selected as water bodies as well, we can actually check. You see that water feature there shows us a negative NDVI value, but if we select this one, you've got a positive NDVI value, which clearly puts a difference between the two of them. But this is not all. We need to be careful. If we select that, it also has a negative NDVI value, but if we select somewhere there, the NDVI values becomes 0.8, which is even higher than this one. So if we decide to put the threshold at 0.48, we might end up with the wrong class. So we're still gonna keep it at 0. At 0 as the threshold for NDVI, and then later on we're gonna see how we can merge these two classes. The only reason this is that high, it might be because there is the presence of vegetation and that's a shallow water, so it reflects a lot of NDVI, so a lot of near infrared. That's why the NDVI value is quite high. So we're gonna append a new process as a classification. We're gonna call it assign class. Dude, stop doing that. Assign class. We're gonna call it an assign class, and then we're gonna take it from level 1. Because we have not classified anything yet, we're gonna filter all unclassed objects from a segmented layer, and then we're gonna specify the condition. So our first condition, we're gonna say, okay, we want you to look at all the NDVI values that are less than 500, that are less or equal to 500. Those features are supposed to be water. The second thing we're gonna do is we're gonna add the NDVI to separate between these water bodies we identified earlier with the other shadows that we identified as water bodies. So we're gonna go into our customize layer and we're gonna say NDVI. We want to look at NDVI, but we want every value that is less or equal to 0 to be assigned to the class that we want, and this is a class we called water. So it's gonna prompt you to select what class or what color you want to assign to the class water, and the moment you click OK, you can see that on the class hierarchy you've got the water class that appears there. So every time you create a new class, it's gonna be listed here. So our first class is water, and then we're gonna say OK. So the next step will be for us to execute the process. The process has executed to less than 0.0 seconds, which was good. So there you go. So all the features that are blue are our water features that we have highlighted. But the question is, how well was our classification? So if we go down there, like I told you, they are neighboring features that are supposed to be water, but were not classified as water. And now we're gonna have to merge them. And I think if we go here, this one should be fine. Oh, no. So we've got also other features that are not classified as water, although they are negative. You see now, because their NDVI values were lower, but the problem is their near infrared values were higher than 500. So they were not classified as water. You see? And that is some of the problems you may encounter when you are doing this. So you need to be really patient so that you can find your solution. So for us to do this now, our next step for us will be to create another class of features that are in direct contact with water bodies that we believe are water bodies. And then we're going to create a class for them and then merge them with water body. For us to do that, we're going to create a new process, or a new a new protocol, I should say. I want it to be a class related feature. We want it to be a real border to. We want all features that are real bordered to water. That's what we're looking for. So if you notice here, this tells you how much percentage of that feature is in direct contact with the water body. For example, this one that we selected is greater than 6% close to water body. If we select that one, it's about 38%. That one is over, it's 50% as well. That one is 45% in close proximity or in direct contact with water. So this should guide us on how to create this layer that we are looking into. So it looks like 30% and above should be a good selection for us to say these are features that you must give to water or assign to water. 30% and above should be enough to make sure we have a good assignment of this layer. Okay, but before we make that decision, I want us to look at the other water body as well and see how it is. So we've got there, that's like 29%, you see. So if we had said 30%, this was not going to be added to it. That one is 0%. It's quite far from water. It's not even in contact with it. That's 42. So I'm going to say 20%. Any features that is 20% or closer should be classified as water, right? So I'm going to add a new process. Call it assign class as well. Level 1 still, we're going to filter all unclassified objects. And then the threshold condition now, we're going to select the relation, the related class feature, related border to water, and we want it to be greater or equal to 20, 0.2. Then we're going to call the new class mist water, because we don't want to merge it to water, just say water, because it's going to have two different classes saying water. So we're gonna, let's just execute from here. Aha, so you see now we've got that part covered. I don't know why this was not, how big was this? Oh, that was 1%. And that was 0.004%. So you see, but you see now we can just create an additional layer, an additional process to compensate for the ones we missed. I want to check how we did on this side. You see, on this side, I think we did pretty well. Although we might have overdone it a bit because we used a lower threshold. We might have overdone it a bit, and we did overdo it a bit. But well, it's okay. It's okay. So this is just something to show you that one needs to be careful when they are running these processes. So I'm gonna try and edit this, because using 2 kind of mess up this one. So I'm gonna use 3. Okay, so it gives us domain is empty, no images object available. So what we're gonna do now is we're gonna create a new process, and we're gonna say delete. Want a process that can delete object level. We're gonna remove the mist water classes. Let's assign it to unclassified, and when we execute that, oh boy, oh boy, what did I do? Yeah, so I think we are sorted. I'm gonna remove that now. Okay, so we're back to normal. So you see, I allowed these errors to come in because I want you to see that this is not just walk in the park. You need to actually think around what you're doing and see what you can resolve your problems. Then I'm gonna correct this process I did here with the classification. I'm gonna say I want it to start at 0.3. Then I'm gonna execute that. That's much better. That is much better. We do not have the mistakes that we had in the previous classification on this side of the image. Then I know we will only have to manage the areas on that side. So if we go back to this water feature here, so you see that only that part was added. If you look at this part, it wasn't added because the percentage is quite low. If you look at this one, it wasn't added because the percentage is quite low. And that one also wasn't added because the percentage was quite low. So the easiest way we can handle this problem is we're first gonna add a process that uh, we're gonna call it grow. Uh, what you call it, we're gonna grow feature, we're gonna we're gonna grow feature to, sorry, I prefer typing them so that it filters for them. We're gonna grow a region from object level 1. What we're gonna filter, water features, and then our candidate class should be the mist water. That's the one we are trying to filter here. Let's execute that. So you see that now what was called mist water has been mixed now with the water class, which is what we wanted all along. So now I'm gonna repeat the same process I did with the water. So we've got a bit of issues here, but that can be edited in any GS software. So because our classification cannot be that perfect. So to solve this problem here, I'm basically going to repeat the same process over and over. So to calculate how the percentage, like for example, this is 20%, that's 20 something percent, that's 30 something percent. So this should resolve this problem again if we repeat that process uh, of assigning missed classes. So if we take this class and if we copy that and paste it here and just edit and say we want it to start at 0.2 now, and say okay, but then now we do not want to move anything from that side. So what we're gonna do is we're gonna try and add a second condition that can actually help us. So we see that NDVI values in this region are quite high. NDVI values in this region are quite high, but the near infrared are below 300. The near infrared are below 300. Let's see on this side what do we have. Features that are in direct contact, for example, that is also like that, but you can see their near infrared is very high here. So we can use the near infrared as an additional constraint to make sure that something else is not added to our classification to this image here. Instead of just saying features that are in direct contact with our border, right? Then that way we do not mess up our classification. So I'm gonna edit this and add the second condition and say I want you to look at near infrared that are less or equal to 300, right? Yes, and then I'm gonna execute that. So from this side we have not messed up anything. Remember, this is sending it to the unclassified, the missed water. So we should have the intended effect on this side. Yes, we got what we wanted. Intended effect, right? Same thing. We can always repeat the process for this thing, but I think this is what we needed. And then we can copy this process again. So you see that this can actually run smoothly for us. Let's execute that then, just like that. And now you've got this feature here that is a 40% somewhere close to that, so you can use this as your threshold again to cover up this thing. But for now, this is basically the process that you actually need to know when it comes to feature extraction, when it comes to water bodies, water features. So you see that we've managed to extract our water features quite perfectly, I should say, in such a way that we got water features separated from every other features from our classification. So the easiest way you can go about this now, if you want to export this, is to add a new process and say export, right? And then sorry, let's say export. So you can export the classification view from level 1 and decide that you want to export only water, filtering from water. And that's the only thing you want to export. And then you can run the process to actually obtain your water layer. It's going to store it into your directory where your information is being kept about the project from eCognition. But until then, this was your boy Benjamin. Thanks for watching this video. Until the next one, where we're going to discuss how we can extract vegetation information from our image classification. Until we finish the entire image, stick with me and you will not be disappointed. Ciao, ciao. This was your boy Benjamin. Till we meet again. Bye.